Hey, Math126 students, just a quick comment. This is a very popular question for students to ask about because it's a big problem. In addition to being conceptually challenging to set up, it leads to challenging integrals to compute. So I always like to give a warning about this, and I do in my lecture video. But I thought I'd make a separate little comment just because I have everything ready here, just about the visuals. So the two functions in question are this and this. So this video I'm not going to talk about solving the problem, but I am going to talk about the graphs. Just a quick analysis of the graphs. The things you should always do, the things you should be thinking about are plotting points. And the points I'm talking about are 0, pi over 2, pi, 3 pi over 2. So the first thing you should do is you should plug those in and plot them if you had to make a graph yourself. Now again, I'd provide, if this was on a test, I'd provide the picture. But take this as an opportunity just to practice that part of the problem. And then in addition, it's good to think about when r equals 0. So those are kind of two things that are always good to do, which you're going to be practicing in the homework. So I did this analysis. I don't think I'll write it up here, but you can see, it's kind of small to see. I'll make it a little bigger for a second. I plotted the points. I got 2, 1, 0, 2, 1. And I talked a lot in my live stream today about the unit circle contains all those values. So anyways, I plotted those. You get this kind of heart-shaped thing. It's always greater than or equal to 0, so that told me it never crossed through or was negative or anything to worry about. Whereas opposed to this one, when I plug in, I do get negatives. So it has this weird behavior that it repeats. So there's kind of some unusual things there that I want to note. And so let's just make a couple notes. Okay, this is always greater than or equal to 0. And now we have a few points to think about. We've got this thing that kind of looks like this. I'm exaggerating the picture, but this is when we're at theta equals 0. And this is theta equals pi over 2. And this is theta equals pi. And this is theta equals 3 pi over 2. And then separately, we have this thing, which ends up just looking like this. But it has this weird behavior that this is 0. This is actually pi over 2 when it gets here. And then this is pi because you end up getting a negative. And then this would be 3 pi over 2. So that's kind of unusual. The big comment here is you'll notice that when this is at the origin, it's pi over 2. When this one's at the origin, it's pi. When this one's pi, it's over here. So this one's unusual because r can be negative. Okay. When you graph those on top of each other, it's easy to get confused because they'll both be at the origin, but it's not at the same theta value. So what I mean by that is if I graph these on top of each other, which is really what the problem's kind of doing, is it's forcing us to think about kind of a more complicated picture. But the point I'm making is it's not the same theta value when they're there. So in fact, if you're facing this way and you got the value out of this function, it's going to tell you this length. But if you plug the same theta value, whatever that theta value is, into that function, it's going to give you a negative. It's going to give you this value over here. So students often make mistakes in this problem of using that value. The goal in the problem itself is to find this area. So if you're using that point to find this area, something went wrong. So something unusual is happening between these two values. Between pi over 2 and pi. This function really is kind of all by itself. It doesn't even, you can do that without the other problem. You don't, from here to here, you don't want to be using this circle. Okay, let me show you a couple quick visuals of that. I'm going to turn that off. So here's the actual thing I was just talking about. If we're just going to kind of look at them one at a time, and let's see. Okay, well, I guess we'll just look at, if we look at this, you can see there's the values. Forget the dotted line for a second. I don't mean it to be dotted. We'll just leave it. So that entire length is that 3 cosine of theta. But notice when you get to pi over 2, you're facing straight up and you're 0. Then when you get to pi, you're facing to the left, but you get negative 3. And you've only gone halfway around through your theta values, but you've already done the full loop of that circle. Okay, so that's kind of unusual. And then when you go to the other curve, it's a different story. So let's see this one in action here. Again, ignore that other one. Let's see if we can get rid of it. No. Just look at that inside dot. I'll make it go slower. Ignore that outside dot. That's the circle. So this one, you're going, you're going, you're going. Here's where you are at pi. That dot up there, you're at 1. As soon as you go past pi over 2, pi over 2. As soon as you go past pi over 2, you'll notice r is still positive for this one, but it's going to be negative for the other one. Let's put them both back there. So you can see if you're trying to find the area of this little region over here, it should not involve the circle at all. You don't want to include that little dotted stuff. You do want to find it. So that's what this problem is. So there's just a few pictures to kind of think about this. So from wherever they intersect to pi over 2, you do want the area between them. From pi over 2 to pi, you only want to be working with the cardioid. You don't want to, you're going to get a negative answer. It's not going to make any sense. Okay, so the point of this problem is to show you one example of something where the pattern changes. If you think about when we used x and y, we saw some examples where, okay, we don't want to do it in terms of x because the pattern changes. The top or the bottom changed. This is the only one in the homework that's like this, but I think it's good in that it forces us to think about this, that the pattern changes. At pi over 2, the inside is now 0. But before pi over 2, the inside is 3 cosine of theta. Okay, so you have to split this problem into two. I hope those visuals help you actually see what's happening. Problem is students make pictures, and if your picture isn't big enough, it's hard to see that in action. So I hope that helped.